Hello students, this is Brock Skaggs. I'm going to make another video demonstration of using SolidWorks to create the parts you see before you. And so we've got this little hamster igloo. It's coming from actually a pet that we had at the house. We named her Nano. That was our little hamster. And so this was her little house. And so made out of plastic. You can see the material, ABS polycarbonate. Units as usual is IPS. And here we're going to say that the isometric view should look something like this, but the origin placement is going to be arbitrary for us. And so this will be the goal. And in sheet 2, as usual, we have the detail drawing here. And so you've got the usual front, top, and right there. We've got two detailed views. Detail A, which is down here in the bottom of the front view, showing this kind of ridge that runs along the perimeter of the igloo. And detail B is right here, showing some of the geometry associated with these little extruded pegs, if you will, that are on top. Notice this thing is largely hollow, so the little hamster can obviously get inside of there and curl up. The shell thickness on it is 50,000ths of an inch. There in the bottom right-hand corner with the global note. We've also got 4 holes at the top. And so that's the overall geometry. As usual, I'd encourage you to pause the video at this point, take a shot at it, and we'll look at mass properties at the end to make sure we're in the ballpark of where we should be. So thinking about how to create this part, some of the different features, well, you've got this kind of cylindrical body, if you will, in the middle there. It's not really a straight cylinder, but it's definitely revolved about some axis, and so we'll use the revolve tool to create it. Then we've got this kind of boss extrude out, which kind of forms the entrance to it. And then we've of course got the pegs on top, which look like they'll be a good candidate for a circular pattern there, because you see you have 1, 2, 3, 4, I think 8 instances there, all revolved about that center axis. I've got the kind of grid-like pattern of holes on the top, 3/16 through all. You could use the cut extrude command for that. The fact that I've put it in as a fraction as far as diameter 3/16 through all is what I'm going to try to use the hole tool in order to do that. And finally, we've got this kind of ridge that runs around the bottom here. That ridge there, we're actually going to use the sweep tool in order to do that. And we might also use something called a composite curve to help us out with that as well. And so that's very quickly the plan for us. And so now let's hop into SolidWorks to see if we can't implement it. And so I'll just go ahead and create a usual part file here. Check units as IPS, which is good. Material, I'm going to hold off on material till the end, just because that ABS polycarbonate, the default appearance is going to be rather transparent. So that might make it a little bit more difficult for you to see when you watch the video of this. And so let's go ahead and start creating this revolve feature. And so I'm going to just get a plane on the, get a sketch, excuse me, on the front plane. And as usual, I'll create the center line first to define my axis of revolution. So I'll just draw it down here. And then what is that profile going to look like? I'll just draw half the profile. I believe we've got lines that go about like this. This line right here is inclined. I believe the angle is 85 degrees. And then we have the arc here at the top. And one thing we know about the arc is it's going to be tangent, so here I'm just applying the tangent relations by holding control down, selecting both entities, and selecting the geometric relation from the quick access box there. So that should be roughly 1/4 of the main body of, say, the front view there, or excuse me, 1/2 of it. And so now let's apply some dimensions now that we got the general shape put in place. So 4 inches is the overall diameter. Again, remember with the centerline tool you can measure either the radius or I can pull across. Here all I'm doing is move my mouse so the cursor is across the center line so I can put in the diameter, 4. At the top it's 2.8. So again, wanting the diameter dimensions here. The angle is 85 degrees, so I'll go ahead and put that in. Arc has a radius of 1. And it looks like that had an issue all of a sudden, so let's go ahead and delete that and see what we have here. Let's go ahead and put the overall height first. The overall height is 2.625. And we've already got the arc being defined for us. Let's see what that is. Radius of 1. Or no, radius, excuse me, is 0.4 there. And so that should mean we've made a mistake, and I can already spot my mistake right here. Notice that the arc does not become tangent to the horizontal line, and so let's go ahead and delete this tangency out by just selecting the geometric relation, deleting it, and then I can go ahead and come in here, apply my 1-inch radius there. And so very important there, I accidentally made a assumption as far as geometry goes. Then I reviewed the drawing when I couldn't apply that R1 dimension and found out what my error was there. So I kind of had to go backwards a little bit before I moved forward on that particular sketch item, which is not necessarily a bad thing as long as we can always catch our errors and correct them before we get to our finalized design. And so with this, let's revolve it about the center line here. So I'm just going to exit the sketch. It's still selected, and I'll go straight into revolve boss and base and hit OK with that. And so now I've got my initial part of the igloo geometry there. And so now we have to worry a little bit about the isometric view. If we go back to sheet 1 here, you can see the opening is right here. And so if I put this in ISO like it already is, I need the opening to be out in this region here. And so the way I'll do that is I'll create a sketch on the front plane. I'll extrude it forward in the positive Z direction using the coordinate system down here in the lower left in order to create that geometry. And so I'll go right into sketch, and we'll start creating the geometry for us. So just the bottom line is going to be midpoint, so make sure it's midpoint here. And here I'll just go ahead and draw a circle. The circle I need to be vertical with the origin as far as the center point of the circle, so I'll apply that. And then let's draw some line segments here. It's the first thing, I'm just making sure that they become coincident with the circle. Then I'll go through, hold control, make sure I get the circle selected and the line, go to tangent. And then I also know that these lines need to be vertical. So here notice I'm going through determining the shape of this thing before I get too tied up on the overall size. The lower part of the circle is no longer needed, so I'll use trim entities to trim that out. And now back to the dimensions. You can see right here the radius 0.875. And then what's the overall height? The overall height's right here from the right view actually, 2.25. And notice here we're going to have an interesting thing happen when we go to dimension, because right now if I pick the arc and the bottom line and apply the dimension, notice it only goes to the center point and not to the very top of the circle. And you might think to yourself, well, I can do the math right. This dimension would just be the one on the drawing, 2.25 minus the radius of 0.875. You could do that, or we could use something else inside of the sketch environment to help us. And so one thing I can do is just left click on the dimension here that I want to change, the 1.38 roughly right now. And on the pane here on the left hand side, not on the value tab but the leaders tab, I can go to something called arc conditions. And so on arc conditions, it's usually based off the center by default, but then I can go minimum or I can go maximum. And notice how it's just changing the location of the extension line there. And so when it's set on maximum, it's showing the very far point of the arc to the other referenced entity. And so that's exactly what I want. And I'll just replace that value with 2.25 exactly. And that is the dimension that's actually shown in the drawing there. And so those arc conditions can be very handy at times. So now we can exit the sketch. If I pull back the drawing, we need to pull that sketch from the center, 2.75 dimensions, to get to the front face there. And so let's go ahead and extrude boss or base. Notice the sketch is no longer selected, so I'll come through here, select the sketch, and go 2.25. Excuse me, 2.75. And so now we can check with the ISO, make sure we're heading in the right direction. And you can see the front here is lining up correctly. This big arc right here is a 1/4 inch arc, I believe. Right there from the right view. And so I'll come in here, go fillet, 0.25 for the feature fillet, and apply it on that edge. That allows me to get that nice blended geometry. So next, let's work on the extrusions at the top here. This pattern of 8 little extrusions. One thing you'll notice as far as when to shell, it's a little hard to see, but the actual hollowed out portions does go up into these pieces, and so I want to make sure I make these extrusion pieces before I shell it, or else these would be solid bodies on top of the hollow area. And so as far as the sketch plane goes, that'll just be the front, or excuse me, the top face, if you will. And so I'll just go ahead and make this sketch here. And we've got, looks like they're centered on a line that would be inclined at 22.5 degrees. And so what I'm going to do is just go ahead and draw a couple lines here. And I'll make the one at an angle of 22.5 with respect to the vertical here. And both these will just be construction entities. So go ahead and get them both selected and tell them to be construction there from my quick access box. As far as one edge is the very edge of the revolve, it appears. And so we'll look into that first, yes. That's under convert entities here. The reason I use convert entities is so I can map that directly to the existing geometry. Next one, you got this kind of construction circle I've created in the top view with a diameter 1.875. That is the other end of these extruded profiles. And then we've got these kind of wedge shapes here. And so the wedge shapes, we'll just start by, let's just draw lines just like so. I'm making the assumption that those wedges trace back directly to the center point here. And some information about it. Well, the detail view here shows that angle is 22.5 degrees. It is going to be centered, so I'll just go ahead and make that adjustment now. So all I'll do is make this smaller angle here, and that's going to be half of the 22.5. And so I'm just going to put equals, select the 22.5 there, and say let's divide that by 2 to create this nice equation-driven dimension. Now, of course, whenever I change 22.5, you'll see that the other is going to update and follow exactly like it should. So we'll change that back to the original. So I don't need all of this geometry, and so what I'll do is I'll go through and trim. I don't need this or this, so that eliminates a lot of those convert entities in that first circle that I drew. I don't really need this part or this part as well. And I don't need this part or this part here. And so that gets my wedge, but now all of a sudden my wedge is not quite fully defined. So one thing I could do is just come in here and say, let's make this line and the origin coincident. And basically what that does is the same thing as having those lines all the way through it. It's going to say, hey, this line, if you would have extended that line, it would have went through the origin itself there. And let's see what we have here is this dimension here. Notice here I've got 0.55 there, and it's really supposed to be 0.475. So let's go ahead and make some changes to that. Here I'm going to go ahead and delete these lines. And we'll change it to 0.475 here. Being careful there. Notice right here I've got a horizontal dimension. What I really want is a line dimension, so I've got to be careful of how that dimension looks before I left click and select it. So there's the 475 there. So you can see this thing kind of wobbles a little bit now. One thing I do know is that these need to be equal in length, so we can go through and make that adjustment. This is out to 3 decimal places. And notice I still have this nice geometry where I extend those right back to it. And so again, that's another one where you can get ahead of yourself a little bit as far as making an assumption. You think you know where it's going, but always refer back to the drawing that you're trying to reference there to make sure you've got the details correctly placed. The 60 thousandths, those are all the fillets associated with these little extrusions. If I show you here, you've got fillets on the top face and then along each of the vertical edges there. And so the ones with the vertical edges we can go ahead and put here. 0.060 has the sketch fillet size. And I'll just go through here and select each of these pieces of geometry. I'll just hit OK on each of those to allow it to do what it needs to do with the relations. And so now I've got a nice fully defined sketch there, so things are looking good at this point. And so what I can do is exit the sketch, go to the extrude boss and base. I have to check from the drawing what that height is. There in the right view you can see it's 40.40, so 400 thousandths. And I've got that geometry. The only other thing I have to do is create the fillets associated with this top face. And so one thing I can do is just select the face. Now here I'm going to use a feature fillet and adjust the radius to 60 thousandths and accept it. The reason I wanted to make that point now is because I'd much rather have the fillet on there before I pattern it as to having the fillet after I pattern, because after I pattern then I have to select all 8 instances in order to create the fillet. Here I'm going to say let's pattern it, pattern both two things. The boss extrude is the first thing, and then we're also going to pattern the fillet 2 feature as well. And so as you'd guess, now we're going to start the circular pattern. So from here you go to circular pattern. Usually I say select a circular edge, but notice here you can't select a circular edge for my reference. So if I come in here, I guess I can select it. There, I just had having issues earlier with the features and faces. Here I could select this, that looks fine. But one thing I can do also, if you ever need to, is use the temporary axes. And so let's go ahead and show those. I can go to View, I can go Temporary Axes here from the drop down. And the temporary axes are basically generated every time you have a circular arc or a circular edge, say like a cylindrical face from an extrusion. It's going to create those. And so just going View Temporary Axis, I can see the axis here. This is the axis that I used in the revolve command. And so I can select it. And the features and faces, I'll come through the little flyout tree and select the boss extrude 2 and the fillet 2. And I do want equal spacing all the way around the circle, 360 degrees, and I believe there is 8 units here. 1, 2, 3, 4, 5, 6, 7, 8, yes. So we're good on the 8 instances. So just accepting that at this point gets us this geometry. Keeping the temporary axes on does make it a little cluttered, so I'll just go down to View and turn those off at this point. But those things do become useful at different times as you start to model. At this point, let's go ahead and put in the shell. So the shell thickness is 50 thousandths. And so one thing I can do here is go to Shell. The thickness is the first parameter there, so 50 thousandths. Do I want to remove any faces? Yes. If you don't remove faces, you'll see I'll just accept it. And from the outside, you can't see anything. But then if I pull off a section of it and move it around, you can see that yes, it did end up shelling the part. You can see the hollow nature of it at this point. But really we don't want that because we want to remove this face and this face. That's the way it actually is on the actual product. And so what I'll do is I'll get right back into the shell command, just left click it and click on the top left icon that's edit feature, or I can right click on it and go to edit feature as well. But here I have some faces to remove. And so I want to remove this face and I want to remove that face. And so you'll see the difference here when I accept the command. Now it creates that shell wall thickness, but it takes away those faces, which is exactly what I was looking for at that point. Excuse me. And so kind of going back to the ISO, we're in pretty good shape. I've got two things left really, the holes at the top as well as the swept entity below, that kind of ridge that runs along the bottom of the part. Let's create the holes first. I'll try to use the hole wizard for it. And so I've got hole wizard here. I'll focus on the position first. And so for the position, I'm just going to select this top face. And I'll just put 4 holes. At this point, just each sketch point is a hole. And then I'll go normal to. And I need to define the position of these holes. And so what I'll do is apply some relations first, saying those two need to be vertical, these two need to be vertical, these two need to be horizontal, and these two need to be horizontal as well to create this grid-like pattern. If I focus in on the top view, you can see the spacing 1 inch centered on the middle of the part, or centered about the origin in this case. So there's the 1 inch, and then here again I'm going to use equation-driven dimensions, so I'll just put equals. Clicking the 1 inch dimension loads the dimension variable name, so D1 at sketch 5 is the variable name of that dimension. I'll say divide by 2 to create the 0.5. And then similarly with the vertical, except for the distance is 3/4 of an inch. So again, I'm going to put my overall 0.75, and then I'm going to come in here and dimension to the origin, put equals. I can just select the dimension, it'll load the variable name in, divide by 2, and it gives me my equation-driven dimensions there. At this point, I've fully defined the location of all 4 of those points, and so I'll go over to Type tab. And to the Type tab, I probably want the hole type here, and so just under hole, fractional drill sizes is what I'm looking for, and I've already got 3/16 pre-populated in there, which is grid. As far as blind, I'll just go up to next. That way it'll go right through this first wall, which looks good, and I'll just accept that in order to create that hole pattern. So far so good. Last we have this little ridge, and the ridge is detailed in the detail A. And so you can see the geometry for the ridge there. Here I'll just create a sketch on this very thin face here. So this face right here will be my sketch face. I'll go Control A to go normal 2. And what I'm going to have is something that looks like 2 horizontal lines here, and then a circular arc. And so this arc is tangent to the lines. So I'll go ahead and apply those geometric relations between the lines and the arc. The height of the arc, 0.1. So that'd be the diameter there. If we were talking about the diameter associated with this circle that the arc is a portion of. And then what is this horizontal dimension? Notice it's 0.18, and this edge right here is actually the inner edge of the igloo. And so I need to be careful there and make sure that I select the inner edge, which is this edge here. Oops. Select the arc, select that inner edge. That should be 0.18. Which, there we go. Notice here, I'm going to have to use arc conditions again. I've got 0.18 currently to the center point of that arc. It needs to be to the far right. And so that's easily changed. Just click the leader. Click the dimension, go to the leaders tab, and we go to max value there under the arc conditions in the bottom. And so I need to adjust this to be 0.18, makes it a little bit shorter. So at this point, the natural instinct here is to close the arc just right here, or close the sketch segment right there. And then what you would want to do is go to the sweep command. But a couple issues will arise. One thing we'll have is the issue that the sweep command won't let us go all the way around the part. And so if you haven't seen the sweep command before, basically what we have is we've got a profile, which is defined by the sketch, and we have to tell it a path. And so the idea behind the sweep is you take the profile and you run it along the path, and any of the volume that it covers is filled with material if you're doing the swept boss and base. The swept cut does the same thing, except for the volume now is removed from any material. So right now we can give it a shot. If we go profile and path, this will be our profile. The next one is our path. Well, you'd say, well, we want to run along that edge. It looks like it's going to do okay for us. And we can even create it at this point. But notice it doesn't go all the way around the part, right? That just gives us a very small bit of it, which is a problem. And so one thing we can do is delete that off. And the reason we have that issue is because we've only got one edge here, and we've got another edge and so forth. But yet, when we go to the sweep tool, we only have one path. There's only one spot to put in here. Notice here on the swept boss and base, you just have one blank here. You can only load one object into that. And so to fix that, what we'll do is go up to curves, and we're wanting a composite curve. And so what this is nice, it allows us to stitch together all of these edges into one curve that can be used as the path. And so here, I'm going to right click on that edge when it's selected, and I'll go to select tangency. And so what that does is it runs along this edge, and anything that's tangent to the edge automatically gets picked up. And so for our case here, it's running along the entire bottom perimeter of the part for us, which is just exactly what we want. And so I'll go ahead and accept that. And so that's looking good. And so let's try once more. We go to the extrude boss or base. We've got our profile. Now our path is the composite curve, and it's showing us the preview. We hit enter, and we get another error. So things aren't looking so great at this point. We've got a zero thickness geometry. So generally, SolidWorks doesn't like it. When you have zero thicknesses, that's basically where you have something like a cylindrical boss, and you're trying to basically draw an extrusion right tangent to that edge, to that circular edge that creates this zero thickness entity. And so it's something similar to that is happening along these curved entities. But we have a solution to it. My solution is going to be to adjust the profile. And so here I'm going to get right back into sketch 7, which is the profile sketch. So I'll edit that sketch. I'll hit Control 8. Now I'm going to be normal to the sketch. So this is back to where we were. And so what I'm going to do is I'm going to basically make sure that there's some intersection between this area that I'm trying to use for my profile and the actual geometry here. And so what I'll do is select it. I'll go construction geometry here, and what I've done is I've just kept that line that I had as a boundary, but now I'm making it construction geometry. And so what I'm going to do is then I'll come off, I'll draw 3 more lines, and then I'll put a dimension here of a very small value, say 0.02. And so what this is going to do is there's going to be always some intersection here. And notice here I've made this value small enough so it's not going to interfere with the inner surface here. It's always going to be maintained within that wall thickness of the part itself. This adjustment here should get us away from that zero thickness error. And so I'll go back and exit again. I think this is the 3rd time for the sweep command. And so I'll go swept boss and base. Again, the profile is the sketch. The path for us is the composite curve. We are seeing the usual preview, and this time it runs through okay without any errors being generated. So take a quick peek at the ISO. It's looking pretty good. Go ahead and change the material. Is ABS polycarbonate, or ABS PC, I believe. I believe that is polycarbonate at the end there. And so we'll hit apply and close. And that should be our in geometry. Let's go ahead and evaluate, show the mass properties as usual. Roughly 0.09 as the mass is good. Roughly 1.56 to 2 decimal places as well, and 0.12 as well. And so it looks like out to 2 decimal places we are good on this part. So this part's a little more complex. You're going to see a few more things, composite curve in there, and the sweeper, I think, new if you're watching these in order. And so thank you for watching the video as usual.